Watch what happens when 3,000 pounds of automotive steel meets 10,000 horsepower of pure electrical fury. This is the Metso Lindemann EtaCrush, the apex predator of the recycling world, operating right here in Commerce City, Colorado. You are witnessing a machine that doesn't just break things, it atomizes them. Inside that armored chamber, a 90-ton rotor spins manganese steel hammers at 900 revolutions per minute. When that hammer connects with a V8 engine block, it delivers 400,000 foot-pounds of torque in a millisecond. The oil inside the engine doesn't just spill, it vaporizes into a blue mist from the sheer heat of impact. Those sparks? That is steel being heated to 2,800 degrees Fahrenheit by friction alone. Every single day, this beast consumes 350 tons of material every hour, that is 5 cars disappearing every 60 seconds. From the moment a vehicle hits the feed rollers to the moment it exits as fist-sized shards of pure profit, less than 15 seconds have passed. The physics are terrifying. The machine uses active torque control to sense resistance, injecting more power instantly to chew through solid axles and driveshafts without hesitation. This isn't random destruction. It is precision engineering designed to liberate valuable metals from their rusted shells. By the time the dust settles on the conveyor belt, what was once a family sedan is now grade A ferrous scrap, ready to be melted down and reborn. This is the definition of industrial violence, and it generates $2 million a week in raw material revenue. To truly understand the shredding empire, you have to look beyond the machine and see the organism. This 45-acre facility in Commerce City is a logistical masterpiece, a node in the global steel network that never sleeps. From the air, the scale is staggering. That mountain of metal near the entrance holds 12,000 crushed vehicles, roughly $4 million of inventory waiting for its turn in the chamber. Below, a fleet of Senebogen material handlers moves with synchronized precision, their grapples transferring 5 tons of scrap in a single bite. But the real lifeline of this operation is the rail spur. Connected directly to the Burlington Northern Santa Fe network, this facility ships over 10,000 tons of finished steel every single week. We are talking about unit trains stretching a mile long, carrying the shredded remains of the American automotive industry to steel mills as far away as Arkansas and Alabama. It is a high-stakes game of volume. Every truck that crosses the digital weighbridge, every kilowatt of electricity surging through that substation, and every gallon of water used in the dust suppression system is calculated to the penny. The infrastructure here is worth over $200 million, designed for one purpose: continuous throughput. When the market is hot, this yard runs 24 hours a day, turning a chaotic flood of waste into a precise river of commodities. This isn't just a scrapyard. It is a critical surface mine, extracting iron, copper, and aluminum from the urban landscape with an efficiency that rivals any natural resource operation on Earth.
Chapter 3: Progressive Material Destruction.
The appetite of the Metso Lindemann is insatiable, but not all meals are created equal. The shredder faces a constantly changing menu, and the physics of destruction shift with every load. We start with light iron, white goods like washing machines and refrigerators. For a machine of this power, these are effectively made of paper. They explode upon contact, the thin sheet metal shredding instantly into what operators call popcorn. The cycle time is mere seconds. But then comes the tangling material, thousands of feet of chain link fencing or bundles of rebar. In a lesser machine, this wire would wrap around the rotor, choking the engine. Here, the sheer torque shears it into 6-inch distinct pieces before it has a chance to bind. The challenge escalates with heavy melt, industrial I-beams and truck chassis. Watch the amp meter in the control room. When a 30-foot structural steel beam hits the hammers, the load spikes from 2,000 to 4,000 amps in a heartbeat. The entire foundation of the building, sitting on massive isolation springs, compresses to absorb the shock. This is where the machine earns its keep. It must shatter solid cast iron tractor weights and shear half-inch thick steel plates simultaneously. The resulting product is a cocktail of densities: light steel for quick melting, and heavy dense nuggets that provide the base weight for the furnace charge. It is a brutal, violent sorting process where the only thing that matters is density and purity. From a delicate bicycle frame to a massive diesel engine block, everything is equalized by the hammer, reduced to its atomic value in a matter of violent seconds. In this business, there is a fine line between profit and catastrophe. That line is defined by the unshreddables. These are the objects that defy the laws of the hammer mill. Solid steel forklift counterweights, train wheels, and pressurized cylinders. When a 600-pound hammer spinning at 160 miles per hour strikes an immovable object, the energy has nowhere to go but back into the machine. This is the moment of truth for the engineers. To prevent the million-dollar rotor from shattering, the Metso EtaCrush is equipped with a ballistic ejection system. Sensors detect the unique vibration signature of an unbreakable impact in milliseconds. Before the operator can even blink, the hydraulic system screams, flinging the massive rear reject door open. The unshreddable object is ejected out the back of the machine like a cannonball, burying itself safely in a sand berm. It is a violent, deafening safety valve that saves the facility from weeks of downtime. But not every danger is solid. Compressed gas tanks, even when empty, can rupture with explosive force. High-tensile wire coils can nest and bind, creating a tangle that threatens to stall the 10,000 horsepower motor. Every load is a gamble. The operators watch the feed cameras with hawk-like intensity, looking for the telltale shapes of danger. A single mistake, letting a solid stainless steel shaft enter the chamber, can cause hundreds of thousands of dollars in damage to the liners and hammers. This chapter is a testament to the extreme forces at play, where we push materials to their absolute breaking point, and sometimes the material fights back. The shredder is the brute force, but the downstream is the brains of the operation. Once the material is shattered, it enters a complex labyrinth of physics-based sorting designed to extract every ounce of value. The first challenge is the fluff, the upholstery, foam, plastic, and rubber that make up 20% of a modern vehicle. We use the Z-Box, a massive air classifier that blasts the falling stream with a 150 mph wind curtain. The heavy metal drops straight through, while the lighter waste is blown away into a separate containment system. It is a hurricane in a box. Now we are left with a mix of metals and rocks. The stream hits the magnetic drums, giant rotating cylinders charged with powerful electromagnets. Watch the defiance of gravity. The ferrous steel leaps up and sticks to the drum, carried over to the clean pile, while the aluminum, copper, and waste drop straight down. This simple magnetic split generates the facility's primary product, ISRI 211 shredded steel. But purity is king. A team of pickers and automated sensors monitors the belt, removing any stray copper wiring. Why? Because copper is a contaminant in steel making. If the copper content exceeds 0.2%, the steel mill will reject the entire load. This separation plant turns a chaotic pile of debris into a chemically certified commodity, achieving purity levels of 99%. It is industrial alchemy, separating the iron skeleton of the car from the plastic skin and copper nerves, preparing it for the furnace. If steel is the bread and butter, non-ferrous metals are the caviar. After the magnets pull the iron away, we are left with a gray, unassuming stream of rocks and debris. But hidden inside is a fortune. This is the realm of Zorba and Zurich, industry terms for the mix of aluminum, copper, brass, and stainless steel. To capture it, we use technology that borders on magic. The eddy current separator spins rare earth magnets at 3,000 RPM inside a non-conductive drum. When aluminum hits this magnetic field, it becomes momentarily charged and is literally repelled, jumping off the belt while the waste falls short. It is physics acting as a gatekeeper for profit. But we go deeper. Sensor-based sorters use X-rays to see through the metal, identifying the atomic density of a copper wire versus a zinc die-cast part. Precisely timed jets of compressed air shoot the valuable copper nuggets out of the airstream at milliseconds notice. We are recovering platinum from catalytic converters, gold from electronic connectors, and pure copper from alternators. A ton of steel might trade for $200, but a ton of this red and silver concentrate can be worth $2,000. In the fines plant, we even wash the dust to recover microscopic particles of gold and copper. Nothing is wasted. This facility generates a significant portion of its $2 million weekly revenue not from the massive piles of steel, but from these small, shiny bags of precious metals. It is the ultimate treasure hunt, automated at high speed, turning the trash of the consumer age into the raw materials of the future.
All right, here's your ticket and $52.50.
Thanks, appreciate it.
This is not just a demolition site, it is a commodity trading floor where the currency weighs tons. The economics of the shredding empire are a high-stakes gamble dictated by the global market. Every morning, the facility manager checks the London Metal Exchange before checking the machinery. If the price of ferrous scrap drops by a penny per pound, the weekly revenue forecast swings by $40,000. The business model is a relentless arbitrage. Buy low from the peddlers and tow truck drivers, process efficiently to minimize cost and sell high to the steel mills. But the margins are razor thin. The operational costs are staggering. Electricity bills that rival a small city's six-figure maintenance budgets for wear parts, and a logistics network that must move 10,000 tons of product every week. A single rail car holds $4,000 of steel. A unit train holds nearly $500,000. These trains connect this landlocked facility in Colorado to ports in Houston and Los Angeles, where the scrap is loaded onto ships bound for Turkey, India, and Vietnam. It is a volatile ecosystem. Holding inventory is dangerous. A market crash can devalue that mountain of steel by 20% overnight. Conversely, timing the market right creates windfall profits. The true product here isn't metal, it is liquidity. The facility transforms the dormant, rusting assets of the automotive world into liquid capital that flows back into the global economy to build the skyscrapers and bridges of tomorrow. It generates $2 million a week not just by crushing cars, but by mastering the art of global logistics. Time is the one resource you cannot recycle. In the shredding empire, efficiency is a religion, and the clock is the altar. We have compressed a grueling 16-hour shift into 2 minutes to visualize the relentless metabolism of this facility. Watch the feed pile. It is a living, breathing organism that inhales derelict cars and exhales raw commodities. The rhythm is hypnotic but brutal. Trucks arrive in a constant stream, delivering the feedstock that keeps the beast alive. If that line stops, the shredder starves and the cost per ton skyrockets. Notice the shadows lengthening across the yard? That represents thousands of tons of material processed. But the real drama happens during the pit stops. Like a Formula One crew, the maintenance team swarms the machine during scheduled breaks. They have mere minutes to enter the crushing chamber, rotate the massive hammers, tighten the liners, and clear the jams. Every second of downtime is measured in lost dollars. As the sun sets, the operation shifts gears. Floodlights cut through the dust, and the sparks from the rotor become a fireworks display against the night sky. The thermal cameras reveal the intense heat generated by the friction, energy that must be managed to prevent fires. This machine doesn't care if it's day or night, it only cares about throughput. The pile of finished steel grows by the hour, a metallic mountain built by the ceaseless grind of gears and the sweat of the night shift. This is a war of attrition against waste, fought 24 hours a day, one car at a time. It is easy to look at a scrapyard and see only destruction and dirt. But look closer and you will see the ultimate engine of conservation. Every ton of steel processed through this shredder saves 2,500 pounds of iron or 1,400 pounds of coal, and 120 pounds of limestone that would otherwise have to be mined from the earth. The environmental math is undeniable. Using recycled scrap to make new steel consumes 74% less energy than producing it from virgin materials. This facility alone offsets carbon emissions equivalent to taking 50,000 cars off the road every single year. It is a critical firewall that prevents our landfills from overflowing. Without shredders like this, the 12 million vehicles retired annually in the United States would pile up in fields and canyons, leaking toxic fluids into our groundwater. Here, those fluids are captured, the mercury switches are removed, and the batteries are recycled. We are closing the loop. The steel from a 1990s pickup truck becomes the frame of a 2024 electric vehicle. The copper from an old alternator becomes the wiring for a wind turbine. Even the water used to cool the shredder is treated and recycled in a closed-loop system. While the process is violent and loud, the result is silence. The silence of a mine that doesn't need to be dug and a forest that doesn't need to be cut. In the circular economy, the shredder is not the end of the line. It is the beginning of a new life for materials that are too valuable to waste.
Deep enough, a little more soil on the left side.
From the chaotic violence of the hammer mill to the silent precision of the X-ray sorters, we have witnessed the heartbeat of modern industry. This facility is more than just a collection of machines. It is a monument to human ingenuity and the relentless drive to extract value from waste. For over 50 years, the men and women of this yard have stood on the front lines of the recycling revolution, turning the rusted relics of the past into the gleaming infrastructure of the future. We have seen how a 10,000 horsepower motor can shatter an engine block in milliseconds, and how a magnetic field can defy gravity to separate steel from stone. We have tracked the flow of materials from the local tow truck driver to the global commodity markets of Asia and Europe. But above all, we have seen that destruction is also creation. Every car crushed here is a new car waiting to be born. Every beam shredded is a bridge waiting to be built. The shredding empire is a beast that never sleeps, a $2 million a week engine that powers our economy and protects our planet. As the sun sets on the piles of Commerce City, the cranes may pause, but the cycle continues. Tomorrow, another 300 trucks will arrive, another 12,000 tons of steel will be processed, and the hammers will swing again. Because in a world of finite resources, the only way forward is to turn the end into a new beginning. This is the alchemy of iron. This is the legacy of the scrapyard. And the empire keeps on shredding.